Okay, we're still in exercise set 69, and we're doing problem number 5 now. And again, my encouragement is to read number 5, piece of paper, pencil, work on it. It could take a long time. It could take a little time. The question is, can you do it without assistance? Now, if you try it and you can't do it without assistance, well, this is a good place to come to watch the video, but also to look at the blue area. So what I want to do is I want to try to do number 5 in a piece of paper and pencil. Now, of course, the abstraction here is I'm using a computer to do the paper and pencil work, but I want to write down number 5 for you as I read it, all right? As I read it. So this is number 5, and we're still in exercise 69. So it says two numbers are expressed by the same two digits. So I'm going to say the digits of the two numbers, whatever they are, there's two digits to them. All right, now I hope you realize the digits of the numbers could be 0, 1, 2, up to 9. That's not too much of an issue for me. But I'm saying they got two numbers. They're expressed by the same digits, but in reverse order. So I'm going to just simply say the digits are x and y. And what would the number be then? So one of the numbers would be 10x. Oh, by the way, the other number would be yx. And these are the digits. X and y are digits. The digits could be 0, 1, 2, up to 9, so to speak. So the first number is 10x plus y. And what's the other number going to be? It'd be 10y plus x. All right? So I know I got two numbers, and really just a reversing of the digits, by the way. And it says the sum of the numbers, well, I can write that down. So the sum of the numbers and again, I'm reading it. It says the sum of the numbers equals the square of the sum of the digits. Well, in both cases, the sum of the digits is x plus y squared. All right? Then it goes on to say the difference of the numbers. Now, if it's a difference of the numbers, one of the numbers has got to be bigger than the other. So I'm going to say this is the big number, big number. Now, big relative to the other number. So what would the difference be? The difference would be 10y plus x minus the smaller number, which would be 10x plus y. So what does it say the difference is? It goes on to say the difference of the numbers equals 5 times the square of the smaller digit. Well, you know what? This requires some thinking. What would the smaller digit be? The smaller digit would have to be x. All right? So here's my problem. This looks terrible. I mean, absolutely awful. It's got so much going on. I'm going to simplify, see what happens. And what do you get? Well, let's see. You would get 11x plus 11y equals x plus y squared. And on the other side, what would you get? Let's see. I got to be really careful, by the way. 10y minus y is minus 9y, right? 10y minus y, and minus 9y. And then x plus, look at that. Did I make a mistake? 10y. I'm sorry. I made a mistake already. I always correct my mistake. Oh, I see a mistake. I'm going to correct it. I don't want to make a mistake. 10y minus y is 9y. Sorry about that. And then x minus 10x, I was thinking backwards, by the way, is minus 9x. I'm still in trouble. I mean, I could do all kinds of wacky things, but I'm going to try to do something because I'm noticing something pretty simple. And I'll tell you what I'm noticing. I'm noticing that these are factorable. So I'm going to write this down. 11 times x plus y equals x plus y squared. And this would be, I'm going to factor a minus 9 out. And this would be x minus y is equal to 5x squared. Well, you know what? It's time for me to think. And thinking takes effort. And I ought to go back but there's two numbers. And I'm going to say x and y can't be 0. And I hope you realize that they're digits. So what are the digits? They could be 1, 2, 3, 4, blah, blah, blah. So x plus y would never be 0 then. X plus y would never be 0. Never. So x and y can't be 0, and x plus y can't be 0. So what am I going to do? I'm going to look at this equation here, and I'm going to divide both sides by a non-zero number. I don't know what that number is, by the way. I'm going to divide by x plus y. And what would you get on that first equation if I divided that first equation by x plus y? And again, I want to remind you, x plus y can't be 0. So what do you get? 11 equals x plus y. Isn't that convenient? Because what I can do now is take this and use it in this equation by making a substitution. What would the substitution be? I don't know. I would say 11 minus x is equal to y. And I'm going to take that and substitute it into this equation over here. And let's see what we get. It's going to be tough, but I'll have to write this down. I hope it's going to be easy to do once I write it down, though. So it's going to be x minus this y. That's minus 11 plus x equals 5x squared. By the way, if things are not easy, I'm probably doing something wrong. So let's write this down. Minus 9, 2x minus 11 equals 5x squared. Let's keep moving and see what we come up with. So it's going to be minus 18x plus 99 equals 5x squared. I want to keep moving. 5x squared plus 18x minus 99. Now, by the way, I know they're integer solutions to the problem, so if they're integers, I gotta assume this is going to be workable. It would be awful if they weren't integers, and I say not possible. Oh boy, this is going to be a tough one, isn't it? So, someone looking at it and saying, I don't know if I could do that. I can take a stab at it. 33 and 3. I got to be careful, though. Minus 3 plus. I'm still going to check it, though. 5x times x is 5x squared. That worked out beautifully. And minus 15x plus 33. Let me write that down. Minus 15x plus 33x. That would be 18x. That worked out beautifully. And 33 times minus 3, it's certainly going to be minus 99. So I have two solutions, by the way. What is my solution going to be? X equals minus 33 fifths, or x is equal to 3. But let me just go back and assure you that this could not be an answer because they're digits. The only digit I could get is 3. So I think I know what y is. So if x is 3, what's y going to be equal to? Well, again, I'm using this over here. It would be 11 minus 3, which would be 8. All right, so I have my numbers, by the way. What are my numbers going to be? One of the numbers would be 83, and the other number would be 38. Again, you can reread the problem if you want, or just simply go back to the answer key, and hopefully we're agreeing with each other that the two numbers are 38 and 83. What do I also do? I want to point out what I do in the problem. I also graph these things out over here to show you that we get points of intersection. But you're going to be surprised when you look at this thing. You might be confused by the graph of it over here because there's other points of intersection we've not discussed. And probably the one that we've mentioned, but you didn't realize, was 0, 0 would be a solution to this problem as well. All right, so we do provide a graph for you. I'm hoping when you're looking at that graph, you're seeing points. All right, and again, I know it's difficult. What do? We just got one integer point, and that's what we're looking for. All right. The graphs might help you though. They also might confuse you to no end. All right. Sometimes I give more information to students in the hope that they look at it and think about it. But the bottom line is confusing you. Give it a little bit more thought. But at some point, like when most things are confused to you, come back later and look at it again. All right. Thank you so much for paying attention though.